This video is about projectile motion, and of course, since Paulina here is a perfect human being, she's going to throw the ball in a perfect parabola. So let's begin with what makes something a projectile. Well, projectile means you have some object that you kick or throw, and there's a component of your velocity in the x direction, a component in the y direction. So we're no longer looking at particles in one dimension, we're not looking at them in two. And a projectile follows a parabolic path, but something important to note is that the only force acting on it is gravity. So if you're going to draw a force diagram, the only force you have is gravity acting down. And that's really all that makes something a projectile. So now let's go over the important equations for projectile motions, and we'll start with the x component of that. Now the only equation you're ever really going to use is going to be that x, or the change in distance, equals the initial velocity times time. And if that sounds familiar, that's good, because you start with the kinematic equation, x equals v initial times time, plus 1/2 times acceleration times t squared. But like I was saying earlier, there is no acceleration in the x direction because there's no forces in the x direction. So that second term, that 1/2 acceleration t squared, just becomes 0 because acceleration is 0. And you're just left with x equals v initial times time. Now in the y direction, it's a little bit different because you do have that acceleration. So the equations you use are y equals v initial times time plus 1/2 a t squared. Use that full equation now because you have the acceleration. Acceleration in any of these equations is going to be 9.8 meters per second per second. Now the other equations for the y direction are going to be the velocity final of force in the y direction equals velocity initial plus acceleration times time, and velocity final squared equals velocity initial squared plus 2 acceleration times y. So those should sound very familiar, and they are very familiar. They're the kinematic equations just in terms of x and y components. You have to break your velocity vector into its x and y components. And the way you're going to do that is to take the velocity that's given to you and multiply it by cosine of the angle that you hit it at. So you're going to have v initial times cosine theta. That's going to give you your velocity in the x direction. For your vertical component, it's very similar. You take your velocity times it by sine theta, because sine will give you that opposite, that up, while cosine gives you that horizontal. And that'll give you your velocity in the y direction. So now that we know our important formulas, let's try a practice problem. And we're going to use this video of Paulina throwing the tennis ball. And for this problem, we're going to say that v initial equals 10 meters per second, and that you throw it at a 45-degree angle. And of course, because Paulina and I are excellent physicists, we measure these exactly, and they're perfectly accurate. So now, knowing v initial and knowing the angle, we can easily find our velocity in the x direction and the y direction. To calculate that, for the x direction, we're going to do 10 cosine 45. That's going to give us 7.07. To do in the y direction, we could do 10 sine of 45. But, as you may remember from trig, 45-degree angle, cosine and sine are the same thing. So we know that v in the x direction and v in the y direction are going to be the same thing. And they're both 7.07 meters per second. So now, knowing that, we want to look for, say, time, the change in distance, and the peak height. So the easiest way to do this now, and for any projectile problem, no matter what you're given, is to write a chart and label what you know or what the problem implies, and identify what you need to find. So to do that, think of it like making a T-chart. On one side you can have horizontal, on the other side you can have vertical. And you want to know for the horizontal the displacement, that's x, v initial in the x direction, v final in the x direction, and acceleration in the x direction. Then over on the other side, you're going to have all the same things, except everywhere you wrote an x, you're going to write a y. So you're going to have y, or the displacement of the height. You're going to have v initial in the y direction, v final in the y direction, and acceleration in the y direction. And then you can start filling in what you know. So we know that the initial in the x direction is going to be 7.07 meters per second. And we also know that the final in the x direction is going to be 7.07 meters per second. And we know that because there's not going to be any forces acting on it in the horizontal direction, and so that number is not going to change. And of course, because it's a projectile, horizontal acceleration is 0. And that's what it's always going to be for any projectile problem. Then we go over to the vertical side. The initial in the y direction is going to be 7.07 meters per second. The initial in the y direction. And the final in the y direction is going to be negative 7.07 meters per second because it's going to go up, but then the velocity is going to be acting in the other direction as it travels back down. And that's how you get that symmetry of the parabola. And then for acceleration in the y direction, we have 9.8 meters per second squared. It's just gravity, and that's what it's always going to be for these problems, unless it's some special situation. So now from this, we don't know x, so we don't know the displacement in the x direction, and we don't know the height, it's y. We also don't know time, but we can find those pretty easily using those kinematic equations listed earlier. So first, the easiest one would be to find time, because that one's pretty important to find the others. And to find time, we want to use that equation of vertical motion, v final equals v initial plus acceleration time. Plugging numbers in, we would get negative 7.07 equals 7.07 plus 9.8 times time. And then solving that, we would get that t equals 1.44 seconds. We can use that to find the displacement in the x direction by just doing velocity in the x direction times time, which would give us 7.07 times 1.44, which equals 10.2. So that's saying that the ball traveled a distance of 10.2 meters. And then to find how high it went, well, in a parabola, because they're symmetric, the peak height is going to be at the center, and that's going to be halfway through the time. So you want to cut your time in half. And then you can use the equation that y equals v initial times time plus 1/2 gravity or acceleration times v initial squared. Times time. And that would get you, plugging stuff in, 7.07 times 0.72 plus 0.5 times 9.8 times 0.72 squared. But it's important to remember that gravity is acting in the negative direction. It's acting down. So you have to make that term negative. So you can either do that by subtracting the entire term or by plugging in negative 9.8. Solving that, you get that the y equals 2.5 meters. So that means the ball traveled a horizontal distance of 10.2 meters. It traveled up 2.5 meters high, which is pretty realistic because one story is about 3 meters and goes a bit under that. And it did that in about 1.4 seconds. And again, we measure those initial values because we are good physicists. So that's pretty similar to how you would do any sort of projectile problem. You want to separate it into your horizontal and vertical components for everything, for distance, velocity, acceleration, and then you'd have time separately because time works for both. And then fill in what you know, and then use kinematics to figure out what you don't, and to work towards your final answer. I hope this video was helpful. Stay classy.